talking in our previous classes how we can try to change interfacial tension. This is some solution you might use in the field, but the way we devise this lecture is for you to understand better how interfacial tension, wettability, and all those principles that we shown you previously work towards residual phase, right? How the mechanisms are in the field. And this is very good to understand that. So you have to pay attention to a co-solvent. A co-solvent is something that could be used to mix either with an apple and water. For example, we pick ethanol. You know that ethanol mixes very well with gasoline in all proportions. And so does ethanol with water. Some people actually drink ethanol with water, right? Or like whiskey or something like that. It's ethanol with something else plus water, okay? But back again, you have ethanol mixing in all proportions with water and gasoline. This gasoline is going to be our LNAPL of choice because it's very common, it's very used. You can pick diesel, for example, also works. We'll make our experiment with gasoline. Well, what we have to understand is when you have gasoline, alcohol, in our case ethanol is our co-solvent of choice, and water, this could be the relationship, the phase relationship could be represented in this diagram. This diagram was developed through my PhD, and you find that on my PhD thesis. Well, at this corner here, we represent pure water. At this corner here, we represent pure gasoline. Gasoline is not a pure component, but we're considering it pure gasoline. Could be pure benzene, for example, would be best. But for our purposes here, we're going to call it like a pseudo-ternary diagram, because this component, you have more than one component, but we will consider it as one. And at this corner here, we have alcohol. Well, if we pick one point here, where the mouse is, you will see that at that point, we have three components. We will have water, we will have alcohol, and we will have gasoline at this point. Well, how do I measure the amount of gasoline? I just pick any line, a line parallel to that crosses through this point. And if this is 0 to 100% gasoline, it will give me the amount in percentage of gasoline that I have in that mixture, ternary mixture. Well, should I pick a line parallel to this one that crosses this point? It will give me the amount of water that I have. And if I pick a parallel line to this one here that crosses this point here, we will have the amount of ethanol. So at any given point in this diagram, I can get the percentage of ethanol, gasoline, and water in my composition. Well, this is not the only thing that we have in this diagram. As you see this diagram here, we have this purple color here. And in this purple color here, we call two-phase region of the diagram. And in this yellow to orange phase here, we call a single-phase region. And these lines here are isodensity lines, because they have different densities. Water has this density here, gasoline that density, and ethanol that density. We have different densities for each phase that we have. Well, the good thing that you have to understand here is that in this two-phase region, should I pick one point here, as we mentioned in our previous slide, this point here, you won't have a single phase with the three components. Let's say I'll get a point exactly in the middle, the very center of this triangle. I will have the exact same proportions of all the components. But as I mix them and I leave them in equilibrium and I wait until they rest and they separate, you have two phases. You have two phases, and each phase will have a different composition. Let's say, if I have a point here, this point here might have one composition here and another composition here. So there is a line that crosses this point here, right? That go through this point and ends up at this line here, right? This line is called binodal line. The line that separates a single phase to a two-phase, and I'll have one composition here at this point of the mouse. I have another here at this point of the mouse. Well, these compositions, these two compositions when I have, well, this one is closer to the water, and this one is closer to the gasoline end of the diagram, right? Here, clearly I have more gasoline, and here I have more water. I'll have one composition where I have water, gasoline, ethanol, and the other composition where I have water, gasoline, and ethanol. Wow! I have two different compositions with the same three compounds. Yes, that's what you have to understand from this diagram. And they have different densities. Still, this density here is lower than that here. You just follow the density, isodensity lines in a single phase, right? And you have one single phase that is exactly at the binodal line, and you have another one, gasoline phase, that is exactly at the binodal line. Well, you have these guys with different compositions. So what I mean is that any given composition that you pick with three components in this region here, that's called two-phase region, any composition that you pick here, we will end up with two separate phases. Two separate phases, either of them containing the three components in different proportions, right? And the proportions will be given by the points where the line that connects the two compositions have their ends in the binodal line, right? Well, what I have is that the compositions are changing as the points that I pick in different points of this two-phase region. Well, what changes is that the new compositions that I have will have lower interfacial tension. Why? Because the original interfacial tension was between water that is in this apex here, and gasoline in this other apex here, right? So when I pick any points that are not in these two ends of the diagram, you end up having a lower interfacial tension. And since our idea of lowering interfacial tension was the idea of pushing the residual phase to a smaller pore, it doesn't get in because the interfacial tension is too high, I'm decreasing the interfacial tension and moving it toward a smaller pore. And I actually try to clean that up. We're going to follow that in the next class, and you see in the sequence, and you will see what happens. Stay tuned.